Okay, so this video is going to be the problems for Module 9 in physics. Okay, so I'm just going to go through each of the problems that are at the back of the chapter, and we'll work through those problems. Okay, so the first one is tells us that we have a 45 Newton child, and the child runs down a road at a momentum, so P is momentum, is negative 9.6 kilogram meters per second. And we want to know what is the velocity. Okay, so we know that P is equal to mass times velocity. So we're going to solve for velocity. So P divided by M equals the velocity. Okay, so the first thing that you need to realize is that Newtons is a weight measure, not a mass measure. So the first thing we've got to do is we have to get that into a mass. So weight is equal to mass divided by gravity. So weight divided by gravity will equal mass. So 45 newtons is a kilogram meter per second squared, divided by gravity, which is 9.8 meters per second squared. So the second squared canceled, the meters cancel, you're left with kilograms. So that the mass is equal to 4.6 kilograms. Okay, so now we know P, we know M, we can just plug everything in and get our answer. So negative 9.6 kilogram meters per second divided by the mass, which was 4.6 kilograms. So kilograms are going to cancel. We'll be left with meters per second, so that the velocity is then equal to negative 2.1 meters per second. And the negative number that we're told the child is running down a road. So the negative number is just to signify that downward direction. Okay, so that's number one. Okay, number two. What is the momentum of a 25.1 gram rifle traveling, or rifle bullet, traveling with a velocity of 351 meters per second at a 45 degrees northeast. Okay, so it's basically traveling at a 45 degree angle northeast. Okay, and we want to know what is its momentum. So P is equal to mass times velocity. And the mass needs to be in kilograms, so if we divide this by 1,000, then we will get that the mass is 0.02 0.51 kilograms, and the velocity is 351 meters per second. So then the P will equal to, momentum is 8.81 kilogram meters per second, and we would say that we need to include direction since momentum is a vector quantity, so at 45 degrees northeast. Okay, so that is number 2. Okay, number 3. Number 3 says a 46-gram golf ball is hit from a tee so that it has a speed of 55 meters per second. If the ball and club were in contact for 0.090 seconds, what force did the club exert on the ball? Okay, so we know that force is equal to delta P divided by delta T. And we know that, so this would be PF minus PI divided by delta T. So we need to calculate PF and PI. Okay, so the first thing that you should realize is that the initial momentum is going to be 0 because the ball is sitting on the tee, so it has no velocity, therefore it has no momentum. So now we can, but then we can calculate PF as being the mass times the velocity. So the mass is 3.46 grams. We need to change that to kilograms, so it's 0.046 kilograms. Times its velocity of 55 meters per second. Okay, so the PF is going to be equal to 2.5 kilogram meters per second. Okay, so now we can plug that number into here. And we already said that PI is 0. So we can put that in there, and then we can put our time in there, and the time was 0.090 seconds. Okay, so the change in momentum divided by time, and we can then solve for F. So 2.5 kilogram meters per second divided by 0.090 seconds will give us 27.7, or with two significant figures, 28. Let's look at units. So we have kilogram meters and seconds times seconds. So that's a kilogram meters over seconds squared, which is a Newton. And that is the proper unit for force. So the answer then would be 28 newtons for number 3. Okay, then number 4 says that we have a soft lump of clay that is thrown at a tree, and we're told that its mass is 456 grams, so I'm just going to go ahead and change that to 0.456 kilograms. It's thrown at a tree at 5.9 meters per second. If how long does it take to stop the clay if the tree exerts a force of 4 newtons? 4.0 newtons. Okay, so again, we can say that F is equal to delta P over delta T. Okay, so what we're trying to determine is time, so we'll solve this equation for time. That gets rid of that over there, and we divide both sides by F, so that delta T is equal to delta P divided by F, divided by capital F. Okay. So now we know that delta P is the final minus the initial. Well, this problem says how long does it take to stop the clay? So that means that the final velocity is going to be 0, and therefore this will be 0. Okay, so we're going to have that delta T is equal to 0 minus the mass, which is 0.456 kilograms, times the velocity, which is 5.9 meters per second. And then we will divide that by the force. And in this case, we know that the tree is exerting the force, so it's going to be in the opposite direction of 4.0 newtons, or I'll go ahead and write 4.0 kilogram meters per second squared. So this is going to be negative divided by negative, which will give us a positive value for time. If we do that math, you should get 0.675. Kilograms cancel, meters cancel, and this second, one of the seconds cancels. This would scoot up there because when you divide by a fraction, you multiply times the reciprocal. So this would be seconds, and if we get that to 2 significant figures, it would be 0.68 seconds. Okay, so that is number 4 in the practice problems. Okay, let's do number 5. Okay, number 5 says that we have a 975 kilogram gun, and an 85 kilogram shell. And the shell fires at 345 meters per second. And we are asked to determine what is the velocity, what is the recoil velocity of the gun. Okay, so if we look at momentum before, so the mass of the gun times the velocity of the gun plus the mass of the bullet times the velocity, so this is gun and bullet. This is before. That is going to equal the mass of the gun times velocity of the gun plus the mass of the bullet times the velocity of the bullet after. Okay, so before the bullet leaves the gun, both the gun and the bullet are at zero velocity. Therefore, momentum in the before condition is zero. Okay. So now we would have that 0 equals the mass of the gun, which is 975 kilograms, times the velocity of the gun, which is what we don't know, that's what we want to determine, plus the mass of the bullet times the velocity of the bullet. Okay, so we're going to subtract this from both sides and divide by that. So it would be negative 85 kilograms times 345 meters per second divided by 975 kilograms. That will equal the velocity of the gun. It's going to be negative. So kilograms cancel, we're left with meters per second. And what we get for that is 30.1, negative 30.1 meters per second for the velocity. We can have just two significant figures. So it would be negative 3.0 times 10 to the 1 meters per second. The negative here indicates that the velocity of the gun will be in the opposite direction of the bullet. So that is a recoil velocity of the gun. Negative 3 times 10 to the 1 meters per second. Okay, so we're halfway there. That's number 5. We have 5 more to go. Okay, so now we look at number 6. And number 6 says that we have a 75 kilogram ice skater. 75 kilogram. And this ice skater throws a 6 kilogram ball, 6.0 kilogram ball at a velocity of -3 meters per second. What is the resulting velocity of the ice skater? Okay, so we know that the mass of the skater times the velocity of the skater plus the mass of the ball times velocity of the ball before will equal the mass of the skater times the velocity of the skater plus the mass of the ball and velocity of the ball after. Okay, so again, just like we have seen before, these at rest, since there's no velocity, these will both be 0. So 0 equals the mass of the skater, which is 75 kilograms, times the velocity of the skater, which is what we want to know, plus the mass of the ball, which is 6 kilograms, times the velocity of the ball, which we are given as -3.0 meters per second. Okay, so I'm going to subtract this from both sides and divide by that. So -6.0 kilograms times -3.0 meters per second. Okay, so this is negative, and I'm subtracting it from both sides, so you have a minus a negative, which is a positive, and we will divide that by the mass of the skater. Oh, what happened there? Divide that by 75 kilograms, which is the mass of the skater. So kilograms will cancel. Negative and negative gives us a positive, and then divide by a positive. So you get 0.24 with two significant figures, meters per second. It is positive, so this is the velocity of the skater. And the positive number just tells us that the velocity of the skater is in the opposite direction of the velocity of the ball. So if the skater throws the ball forward, the skater will, if we define that as negative, then the skater will move backwards. The skater will move in the velocity of the skater will be in the opposite direction of the velocity of the ball. Okay, so that's number 6. Number 7, we have a 20 kilogram railroad car, or 0.20 kilogram railroad car moving at a velocity of 0.24 meters per second. And it is struck behind by a 0.42 kilogram car that is traveling at 0.45 meters per second. And then it tells us that the two cars stick together when they collide. So what will be their final velocity? Okay, so we're going to have the before and after, the mass times the velocity of the car 1 plus the mass times velocity of car 2 will equal the combined mass, so mass 1 plus mass 2. So the mass of both times the velocity of both. Okay, so the mass of car 1 is 0.20 kilograms times 0.24 meters per second plus car 2, 0.42 kilograms times 0.45 meters per second. Oh, yeah, okay. Okay, so that's the before condition, and then the combined mass would be the 0.2 plus the 0.42. So the combined mass would be 0.62 kilograms times their velocity. Okay, so I'm just going to solve by V by doing just dividing both sides by 0.62 kilograms. So this will cancel. The kilograms are all going to cancel. And you'll be left with meters per second. So this plus this divided by that will give you 0.38 meters per second is the velocity of the two cars when they are connected together, when they're stuck together. Okay, so one car slammed into the back of the other, and the two cars stuck together and continued to move, and they move at a velocity that is somewhere between the velocity of the two separate cars when they were moving separately. And the cars, because it's a positive number, and the initial velocities were also positive, that tells us that the two cars that are stuck together will move in the same direction as the initial velocity of the two cars. They were both moving in the same direction because one car slammed into the other car from behind. Okay, so then the two cars that are stuck together will continue to move in that same direction. Okay, number 8. We have an 895 kilogram freight car that is coasting at 3.1 meters per second. And a crane drops 365 kilograms of junk into the freight car. What is the freight car's new speed? Okay, so again, because of the law of conservation of momentum, we know that mass times velocity before will equal the mass times the velocity after. So this is the before, when you just have the truck times its velocity. And now, and then you're going to have the mass of the truck plus the mass of the junk that was put into it. So their combined masses, the combined mass is 1,260 kilograms times the the new velocity. Okay, so we're going to solve for v by dividing both sides by 1,260 kilograms. So kilograms will cancel. If we do this, this will cancel. So if we do that math, we will get that the velocity of the truck with the junk in it is 2.2 meters per second. Okay, 2.2 meters per second. So because we increase this mass, that meant that the velocity had to decrease from its original velocity. So it went from 3.1 to 2.2. Because of the increased mass, the velocity had to decrease so that we could conserve the momentum. And the last two problems deal with angular momentum. And remember that we defined angular momentum using the letter L is equal to mass times velocity times radius. And what we are told is that an object has an angular momentum. So L is 4.5 kilogram meters squared per second. And we has a mass of 0.25 kilograms. And it travels at a speed of 3.5 meters per second. What is the radius? Okay, so we're just going to solve this for r. So L divided by mv will equal r. Okay, so 4.5 kilogram meters squared over seconds divided by 0.25 kilograms and divided by 3.5 meters per second will equal r. Okay, so kilograms are going to cancel, seconds will cancel, and this meter will cancel, and so we'll be left just with meters for our radius. So 4.5 divided by this and divided by that gives us, with two significant figures, 5.1 meters will equal r. So the object moving around in a circle, the radius will be 5.1 meters. Okay, and lastly, number 10, also an angular momentum question. In this one, we have a rock twirled at the end of a string with a speed of 5.6 meters per second. And its radius is 34 centimeters, so I'm just going to put that as 0.34 meters. And if the string is suddenly let out so that the rock travels with a speed of 3.2 meters per second, then what is the new radius? Okay, so law of conservation of angular momentum. We know that the L before has to equal the L after. So mvr before has to equal MVR after. Since mass is on both sides, we'll ignore that. So then we can just do VR before equals VR after. And we need to know the new radius. So VR before will be 5.6 meters per second times 0.34 meters. And that will be equal to the new velocity, which is 3.2 meters per second times the new radius. Okay, so we're going to solve for r by dividing both sides by 3.2. So divide both sides by that. That gets rid of that on that side. And we'll divide this side by 3.2 meters per second. So again, this meter will cancel, seconds will cancel, we'll be left with meters. So 5.6 times 0.34 divided by 3.2, and I get 0.595 meters is equal to the radius. So when the object slows down, its radius is going to increase to get that slower speed, and we can have two significant figures, so this would be 0.060 meters is equal to r. Okay, so those are the practice problems for Module 9, and if you can work the types of problems that are in that we've just gone over, you should be in good shape for the test. Thank you.